Well, hello again, and welcome to Will Henry's modestly equipped gun shop, or workshop, where it's mostly gunsmithing, but not always. So I had somebody ask if I would show a little more about aligning the tailstock, especially in regards to chambering a rifle barrel. So I'm going to show that in this segment. So we'll turn you around so you can see the lathe. There we go. Okay, so in general, you know, the lathe makes things round, and just how round it makes it and how straight it makes it is dependent a lot on the bearings and the lathe and the chuck and so on and so forth. Now, in this case, I've got the 3-jaw self-centering chuck on, and I just thought I would just briefly see just how self-centering it was. I haven't checked it for a while. And so there we go. I've got, see if I can zoom you in a little bit. And I'll get up a little closer here. A little better angle. There we go. So with this particular 3-jaw chuck and this piece of material, this is a piece of induction hardened chrome plated shafting. It's used for the rod in a hydraulic cylinder. And this stuff is it's very round, but not necessarily super straight. Like it's pretty straight, but it's not 100%. If you want a piece that's 100% straight and 100% concentric to the centers that are cut in it, you need to get a certified test bar. But this is kind of a poor man's test bar. But like I say, it is very round, and so you can see in this particular 3-jaw chuck, which is a pretty good one, I show a total indicator run out of only about a 1/2 thousandth. So the piece is really only offset by about 2.5 10,000ths of an inch, which is pretty darn good. Now, just to show another thing, as good as it is, no chuck's perfect, and generally speaking, the jaws aren't perfectly aligned with the machine, and just how far off it is. Oops. In this particular case, it's showing about 12 thousandths, and now I'm going to show you something. If I turn this, set it up again, now it's only showing about 5, and that's because, like I say, the bar is not perfectly straight, and so in checking for this, I can't really trust this bar if I'm wanting to see how straight the chuck is. As it happens, this chuck is quite straight, and I would normally expect to see somewhere around 5 thousandths run out this far out ahead of the chuck, and that's just fine for the most part, because any turning you're doing that's unsupported is done close to the chuck. So anyway, the other thing that that a person has to be concerned with his lathe is whether or not the headstock is coaxial with the bed of the lathe. That is, everything is aligned perfectly, because if it's not, you could put a piece in here and turn it and it would be tapered. So that when a person's setting up the lathe for the first time, one thing you would do is perhaps do a turning test and turn a piece, say 6 inches long, and then you would measure it with a micrometer at each end and see how much taper you had. and ideally, of course, you want 0. And as it happens, this lathe gives me that because it was set up that way. Now, but the question was about the tailstock, or the other end of the lathe. I'm just going to move the carriage up out of the way here. Now, back down. Now the tailstock is, when everything's as it should be, the tailstock is perfectly aligned with the axis of the headstock. That is, the point of this center here, it's very sharp, the point of this center, if you had a center in the other end, they would align perfectly. And indeed, that's one way that people would check the alignment of the tailstock with the headstock, is they have a center at each end, and then they can bring the centers up together, or they'll have a pair of buttons that sit on the centers, and by measuring across the buttons, they know when it's aligned. But that's not how we're going to do it. So what I'm going to do is, as much as I hate to start with, I'm going to wreck the alignment of my tailstock. Now, if I was wanting to turn a taper, I would adjust my tailstock so that it was offset toward the tail post, the tool post, and that way anything I turned that was supported by the tailstock would be smaller at this end than it would be at the other end. And so there we go. Now we've offset that. And another thing I should mention, if you're turning a taper that way, by offsetting the tailstock, you cannot hold the workpiece in the chuck, because if you're doing that, all you're doing is bending your workpiece over. The workpiece has to be supported on a center on the other end, so that it's free to move over. And I've explained that before with the, and I think might even have shown it with the backing plate and using a lathe dog to drive the work. But anyway, now that I've set this off to the side, I can check to see just how much by just mounting an indicator in the on the chuck here. And then bring it around to where I can. Okay, let's see what we got here. Okay, now, once again, I'm going to try and bring this around so that we can see just a little better here. Okay, so you can see as I move this around, you can see how the dial, now there's not a lot of range of motion in this particular dial, so that I can't bring it all the way around and show how far it's offset. In order to do that, I'd have to set up a dial with more travel. But in this case, it's probably offset, oh gosh, by a 1/16 of an inch this way, and that would mean that anything I turned would be an 1/8 of an inch smaller on this end than it would be back on the other end. So, our alignment wouldn't normally be this gross if we were just setting up the chamber, but we would be wanting to check it anyway. So to try and get it back to where it should be, it's going to be kind of mandatory here, I guess, for me to get in the way, and I apologize in advance, but there you have it. So let's bring this back a ways. Okay, now at this point, let's see, we're at 8 thousandths. Let's see which way we're going there. Okay. And if we go back the other way, now you can't see this. Let me see. Normally I have a mirror somewhere, but I can't locate it quickly. I'm not going to waste a lot of time looking. But you'll have to take my word for it. This is it was back at 0 on the other side, and like I said, on this side it's at just past 10 thousandths. Well, actually, 25 thousandths from 0, and back on this side 0. So I'm still 25 thousandths this way. So I'll move it back some more. So now at this side we're sitting on 8. There's over 10. Now we've gone a little too far. So down to about 9 there. 9.5 here. Okay, so now I've got it reading at about 9 1/4 on both sides. So now it's aligned laterally. Now, one thing I wanted to show is it's sitting approximately approximately 1,000th high still. And now the reason for that is that the lathes are generally made that way. The headstock usually sits just a little higher than the tailstock. And before I had started here, I had let the lathe run for about 10 minutes, but it really needed a little longer to warm up. But once it's run for 20 minutes or so and the headstock is well warmed up, the bearings are warmed up, then there's enough expansion there that the height takes care of itself. And but that's always something that's there, is the potential for a little bit of error up and down. And like I say, that varies according to the temperature of the headstock. But anyway, so by sweeping around this center, we can ensure that at this point the tailstock is perfectly aligned with the axis of the headstock. And if we have a barrel mounted in here and we're running a reamer into it, it's going to ream on size. And if the tailstock's offset to one side or the other, or if there's too much up and down, whatever, if it's misaligned by too much, you'll cut a chamber that's slightly oversized, equal to double the amount that it's offset. So if it was offset 2/1000ths of an inch, then you could potentially cut a chamber that was 4/1000ths of an inch oversized. Now, it's not quite that bad because it depends on how long the shank of the reamer is, like how far it's cutting up ahead of where the center is supporting it, and so on. And that's all just simple geometry. The person can figure it out if he cares to. But this not being a math class, I'm not going to go too far into that. So anyway, that's about it. This is how you check. Now, going a little further, when the tailstock's aligned this way for reaming, it is also aligned quite well for turning, but this doesn't guarantee that you could mount something between centers and turn a true shaft, because like I say, you would have that height difference. And then of course, as you move up and down the ways, lathe ways are pretty good, but there again, they're not always perfect. And if the lathe has been carefully set up and isn't badly worn, then it's going to be pretty darn good, but it may not be perfect. So that's why if you're turning a shaft, a person would set the shaft up between centers, and he'd take a cut, and then he would measure at each end of the shaft to see what variation there might be. He would also measure in the middle to see how much deflection was occurring, because the shaft might tend to deflect away from the tool a little bit, or it might tend to climb up on the tool and get smaller in the middle. So these are all things that the person has to look at. Now, with this piece of IHCP that I had in here, see if I can demonstrate some other stuff here. With my luck, it'll everything will go wrong here, but we'll see. So I'm going to switch centers here and just put in the ball bearing center. So we had previously checked this, and the second time I set it up, now I've got it hanging out a little further. And I'll go back and check at the back end here again. and there again is running out. Well, it's showing almost 1,000, 3/4 of 1,000, and out here at the end, well, heck, it's only showing 3. I was hoping for more. In fact, I'm going to see if I can't mess that up a little bit. If I turn it. And like I say, I think a lot of this is because this shaft is not perfectly straight. Well, that's about as bad as we're going to get, I guess. So 5/1000 of an inch. But anyway, so at this point, I can bring the tailstock in. Switch this around. Well, now we're showing about 2. So that may be my center's a little eccentric, but probably what it means is that because I'm holding this in the chuck, it's trying to just bend the piece over, and a shaft this stiff isn't going to bend very easily. There, I tightened up the tailstock, and yeah, now I'm down to about 1,000. So now, if I was to turn this, in theory, I could end up with a pretty straight shaft, but whether or not it would be perfect, there again, it would take a turning test to tell. And of course, the other thing is that without ceramic tooling, you're not turning that at all because it's too darn hard. But anyway, the other thing is that with a certified test bar, you can set up between centers, and then you can check over the length of that bar just how well you're set up. But again, that doesn't necessarily mean anything if you're using a tailstock to push a reamer. To use the tailstock to push a reamer, the best way is to indicate the tailstock as I showed you, and end up with it centered up with the headstock. And if you do it up in that area, you're going to be pretty close. If you're chambering with the barrel held in the headstock. Now, if you're chambering with the barrel held in the steady rest, it's a little different because the barrel is centered up by the tailstock, so that any minimal error in the tailstock you can compensate for, providing the outside of the barrel is running through. But we'll get into that more later when I have the opportunity to set up a barrel that way and show you how that works. But for now, I think we've done enough, and as soon as I find my remote, which is easier said than done. Oh, there we go. So that's it for this segment, and I hope there was some information of value there for you, and we'll see you next time.